Welcome to 2.8 video lesson underneath Algebra 2. The concept is two variable inequalities, and there's only 4 boxes to talk about. So here we go. Box number 1. Let's talk about linear inequalities, a boundary, half planes, and test points. Whew, lots of stuff to talk about in number 1. Okay, on the left-hand side here, I have graphed for you a very, very basic function, a linear function, or y equals x plus 2. This should not be any big deal to anybody watching this video. So you notice that the y-intercept is 2, and then the slope, of course, is 1. So any point that is on this line right here would make this a true statement. For example, if I took the point 1, 3, x is a value of 1, y is a value of 3. So isn't it true that 3 is equal to 1 plus 2? Yep, 3 is equal to 3. Yep, of course, that's what that means. So the point here is that I want you to understand that any point on the line makes this a true statement. Okay, now look, all I'm going to do is I'm going to change the equal sign to a greater than sign. So that's all I did over here. And now look at the picture. Well, you can clearly see that this thing definitely looks different, right? The line is still there, but there's a darker side and there's a lighter side. So this down here, the y is greater than x plus 2, that's a linear inequality, okay? Because all of a sudden now I've changed from a linear equation to a linear inequality. And you can see that it creates a boundary, right? The boundary is like there are two half planes here. There is this half plane and there is this half plane here. So the boundary would be everything above the line or below the line. So that's kind of what the idea of boundaries mean. And then the idea of test points. Well, okay, so how do I know which way to shade this particular linear inequality? One way that we do it is we take a test point. And I always say take the easiest test point you can find. So take 0, 0 and plug it into your linear inequality. Is it true that 0 is greater than 0 plus 2? So is 0 bigger than 2? No. 0 is not bigger than 2, so I would not shade the side or the boundary of the side that has that point on there because this is a false statement. I want to make true statements out of this thing, so I would choose to shade everything that is above that line right there. So that's the idea of test points here. So we have 4 words, so linear inequalities, boundaries, half planes, and then test points. The thing I did want to talk to you about is, I'm not sure if you can see it, I will try and zoom in right now for you. There we go. Can you see that this line right here is a dashed line? The reason it's a dashed line is because that inequality is strictly greater than. So any point that's actually on that line is not a member of the solution set. So if I had a greater than or equal to sign, then I would have a solid line. So anything that is greater than or equal to would be solid, or less than or equal to. But anything that is strictly greater than or strictly less than would be a dashed line right there. So I did want to talk to you about that, make sure that we did understand that part there. So there is box number 1, all about linear inequalities. Okay, box number 2, let's graph the linear inequality y is greater than 2/3 x minus 3. So the first thing that you might want to consider doing is just treating it like an equal sign. Y is equal to 2/3 x minus 3. This is pretty straightforward. The y-intercept would be -3, and then the slope would be up 2, 1, 2, and over 3, 1, 2, 3. All right? So if I was graphing this line right here, I would just go ahead and graph this, and I would be good to go. But because I want a linear inequality, I have to make sure that I consider whether this line would be solid or dashed. And in this particular case, because it is strictly greater than, my line would have to be a dashed line. So I'm going to go ahead and make it dashed for you right now in red, which is kind of hard to see, but that's what I'm doing here for you. And then I would take a test point because I don't know to shade. Do I shade above this line or below this line? So I'm going to take the test point of 0, 0 and plug it into my inequality and see what I get. So is 0 greater than 2/3 times 0 minus 3? So is 0 bigger than -3? Is that a true statement or a false statement? Well, that's true because 0 is definitely bigger. It's to the right of -3. So therefore, I know that the side that has 0, 0 is the correct side to shade. So I would shade all this stuff above this line, and my line would be a dashed line. And that's how you would graph a linear inequality. Okay, box number 3 is a U-try. I have given you the picture of a linear inequality. you can clearly see the line. It is a dashed line, and you can clearly see the boundary, which is like to the lower right-hand side here. I would like you to come up with the linear inequality that represents the graph below. Okay, hopefully you got the right answer of y is less than x minus 1, but if you did not, let me show you how you could do it. The first thing that you would want to do is write down the linear slope-intercept form of an equation, y equals mx plus b. Then go ahead and look at the line and get the intercept and the slope. And so the y-intercept is down there at -1, which is clearly located right there, and the slope is 1. So therefore I get to here. Now the question is, what do I do? Do I create a greater than sign, or do I create a less than sign? So what I like to do is I take a test point that I see that's in the region. So I took the test point right here, that test point of 1, -1. So my x is worth 1 and my y is worth -1. And what I did was I substituted that. So I substituted a -1 for y, I substituted a +1 for x, and then I brought down the -1, and I left a space in between. And what I'm trying to do is create a true statement. So go ahead and figure this out. Okay, 1, how does -1 compare to 1 minus 1? -1 is, how does that compare to 0? Well, -1 is less than 0. So that's the sign that I know to use inside my inequality. So y should be less than x minus 1. And that's one way that you can do it to create the linear inequality. I think this is the most accurate way for students that I have found over the years. Okay, box 4 is an example that we're going to do together, and we're going to graph now the absolute value inequality. Y minus 4 is greater than the absolute value of 2 times an x minus 1. Okay, perfect. So we can take what we're learning about absolute value inequalities, regular linear inequalities, and apply them to absolute value. So the first thing that we want to do is we want to write this in a form that we can better understand. So if I start with y minus 4 is greater than or equal to 2 times the absolute value of x minus 1, I'm going to add 4 to both sides. So y is going to be greater than or equal to 2 times the absolute value of x minus 1, and then plus 4. In the previous video, I learned that this -1 is going to move my graph 1 unit to the right. And this plus 4 is going to move my graph up 4 units. And this 2 is going to give me a vertical stretch by a factor of 2. So if my original graph for absolute value of a parent function starts at 0, 0, I'm going to go 1 unit to the right and then 4 units up. And then instead of having a regular up 1 over 1, I'm going to be going over 1 and then up 2 because I have vertically stretched by a factor of 2. And since this graph or this inequality is greater than or equal to, I know that I'm going to have a solid line going up like this and a solid line going up like that. So now the question becomes, okay, do I shade on the inside of this V or do I shade on the outside of this V? And again, we answer that question simply by taking a test point. So this point right here, to me, looks like the point 1, 6. And that point is inside the region. So I want to test 1 and 6, where this is the x value and this is the y value. So let's see here. Let's say, how does 6 compare to 2 times the absolute value of 1 minus 1 and then plus 4? So how does 6 compare to 1 minus 1 is 0, 2 times 0 is 0, and this is a positive 4. So 6 is definitely greater than the number 4. So then I know that that's a true statement. I have come up with a true statement. So if I have come up with a true statement, I know that that point must be a point that is inside the shaded region. So therefore, I know that I'm supposed to shade everything that's on the inside of my V right here. Again, this is kind of tricky and it will take some practice, but we will practice more in class. But this is the basics of how we graph absolute value inequalities.